Evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the presentation on heavy snowstorms across Hampton Roads, Virginia, across the Hampton Roads cities of Virginia. I'm going a little bit closer, a little bit more local on this particular video this evening. This is a pretty funny video or a picture here to start things off. I mean, there's a lot of snow on the ground when you see a dog. A dog is helping to push this car forward out of this snowbank. So I thought that was pretty funny to take this picture from a previous winter storm. I believe this was 1980 storm across Hampton Roads, Virginia. But this dog, it's pretty funny to look at this. So anyway, a lot of interesting facts. I went back and looked at the previous heavier snowstorms across the area, across Hampton Roads, Virginia cities. Let me go ahead and get my laser pointer set. So the purpose of this particular presentation was to examine the increasing frequency of heavy snowstorms across southeastern Virginia, specifically the Hampton Roads area, since 1980. So I went back just over 40 years. And although this particular area sees a great or wide range of temperatures during a typical winter season, the data does appear to point to an increasing trend in the number of heavy snow events across Hampton Roads. And by the way, for this particular research, I'm considering heavy snow to be a 6-inch or more snow event. Right, so first let's take a look at some of the top 10 Norfolk snow totals or events of various monthly high amounts or particular events, like I said, whether it's seasonal or monthly. And this data is courtesy of the National Weather Service Forecast Office in Wakefield, Virginia. All right, so looking at all the data here, okay, on the right, showing you the all-time record snow events up here in the upper right, their top 15 events for the categories. I even have Richmond, Virginia on here, as well as Salisbury, Maryland. But I'm really focused tonight on the Norfolk, Virginia area, since that's the Hampton Roads area of Virginia. But generally, we have the top 15 events here in the center column at the top for Norfolk, Virginia. The biggest event being the 18.6-inch storm on December 27th to 28th of 1892, followed by the 15.4-inch Snowfall event from February 17th to the 19th of 1989. And then as recent as 2010, many of you who live in the Hampton Roads area really remember this storm. It started snowing on Christmas Day on that night. And by the time it was done on the 26th of December, there was 14.2 inches of snow on the ground. Looking at the bottom here, also showing top 15 events. These are all-time record daily snows, so generally over a 24-hour period. Some of the bigger totals in just 24 hours was 17.5 inches. That's that December 27th snowstorm of 1892. So that shows up twice. Number 2 on the all-time daily record snowfalls was 13.6 inches on February 18th of 1989. That 89 winter season was a doozy as far as snow totals across the Hampton Roads area. And there's that 13.4 inches, number 3, in December 26, 2010. That shows up number 3. So one other thing I want to mention about this particular image here on the right is notice how these events are different for both Richmond and Norfolk, Virginia, okay? You don't see, for example, the number 1 all-time record snowfall event in Richmond occurred in 1940 in January, and you don't see the same system as the number 1 for Norfolk, Virginia, right? Number 2 in Richmond, here it is, 19.1 inches. And in Norfolk, it was a different date. In Richmond, it was 1922, and then in Norfolk, it was 1989. So, very interesting material here this evening. And then the bottom left here, I do have some other information. For example, 5 of the 15 events that are listed here, 33% of those were heavy snow events occurring since 1980. 4 of the 15 events over here for Norfolk, Virginia, or about 27%, set daily snowfall records since 1980. And then 3 of the top 10, 33%, or about 1/3 of the snowfall seasons, have occurred since 1980. And here, by the way, on the left, is the actual breakdowns of numbers per month, generally showing you the average over a winter season is about 6.2 inches for the Hampton Roads area, specifically Norfolk. In the month of December, the average is 1.1 inches, but then you can see some of the higher totals for the month of December. January, the average snowfall is about 3.2 inches, and then in February, 1.5 inches. And you can see some of the higher monthly snowfall totals here, okay? So for example, 1892 in December, that set the all-time record for December snowfall in Norfolk at 18.6 inches. 2010 came in second place, again more recent, at 17.8 inches. And then for January, the most snow that occurred in the month of January is 1966 at 14.2 inches. And there's 2018. And that was a pretty interesting month as well around Norfolk, Virginia. And as far as these different dates between Richmond and Norfolk, Richmond is further inland. It's about 100 miles away from Norfolk, 100 miles away from the water. That water tends to really act as a modifier of the air temperature. And if you get a strong wind off the Atlantic into the Hampton Roads cities, a lot of times what happens is that marine layer air typically warms the planetary boundary layer just enough for events to maybe start off as snow but go over to rain or remain a cold rain. And a lot of this has to do with storm tracks. A further out storm track off the coast is going to favor the Hampton Roads cities, and then the storm track that's a little bit further inland might favor I-95 more, and Norfolk might be in the warm sector of the storm, or they might be in another bad area. All right. Going on to some of the snowfall facts for Hampton Roads, Virginia. Outside of 2010, the 14.2 inches, that event, as well as 1958, where 11.4 inches of snow fell, and then 1892, where 18.6 inches of snow fell. The heavy snow events are not very common in December across Hampton Roads, okay? Outside of these 3 years. And you can kind of see they were oddities or abnormalities. Of the top 15 snowfall events dating back to 1892, there were just 4 of the events which occurred in December out of the 15 total. And also just 4 of those events occurred in January, 5 occurred in the month of February, and only 2 events occurred in the month of March. March 1980, the Circus blizzard was one of those. Now, the most snowfall in one particular event in the Norfolk area occurred on the 27th and 28th of December of 1892, when 18.6 inches of snow fell across the area, with the most snowfall in 1 month occurring in February of 1989, 24.4 inches in 1 month in February of 89. The most snowfall in one season occurred in that winter of 79-80, in which the area in one particular winter season, Hampton Roads areas, particularly Norfolk, recorded 41.9 inches of snow. So you can see how much above normal this is, right? When I talk about 6.2 inches as average, and then I show you a figure like 41.9, yeah, really high above the average mark for a winter season. Here are the winter temperature ranges for the Norfolk, Virginia area, and this is for the month of January, okay? But this is very typical across this area, okay? January 2016 is over here on the left. This is at the Norfolk International Airport, by the way. January 2017 in the middle, and then January 2018 on the far right. Generally, what you see are these bars represent the highs and lows for particular days within these Januaries. And you notice how the range can go anywhere. Let's say January 10th, 2016, the high was 67 degrees. And then the next day, the high was only 45. Here's another example. So it was only about 47 degrees Fahrenheit on January 25th, 2016. And then we saw a crazy rise in temperature up to about 66 degrees Fahrenheit. So you see how you have a lot of ups and downs in the temperature patterns throughout the winters in Hampton Roads. A lot of this has to do with wind direction. and of course the proximity to the modifying effects of the Atlantic Ocean nearby. Typical water temperatures in a season are generally in the lower 40s. So if you get a stronger wind shift off the water, that can modify the air mass. Additionally, if you got a main storm track back toward the Appalachians, that's generally going to tend to favor warm air advection, a stronger low-level jet, which is going to result in warming temperatures and generally rain events in the Norfolk area. Here's January 2017 again. You can kind of see these ups and downs again. I mean, January 10th, 2017, high temperature 44. A couple days later, your high temperature is almost 70 degrees. All right, so you can have swings like that. 45 degrees one day, 65 to 70 and a couple days later, and then it comes crashing back down again in January. All right, so just look at the wide range here. Lots of temperature volatility in the record overall. Now, let's take a look at some of these major snow events, heavy snow events for the Hampton Roads area. I took all these charts from the particular events to kind of show you what they look like from the NOAA Daily Weather Maps website. And starting off with the 6th and 7th February 1980 major snowstorm across the Norfolk area. This is an interesting note up here at the top. This is the second biggest snowstorm ever recorded at Norfolk, Virginia. So whoever archived this and saved these charts, they actually made this note. So I thought that was really interesting. Now, there's 20 inches of snow, this handwritten note says, at Elizabeth City, North Carolina. So just phenomenal snowfall totals. Generally, here is what the surface chart looked like for Wednesday, February 6, 1980. You had an area of low pressure which has developed off the coast of Georgia along a stalled frontal boundary. You got a lot of precipitation overrunning colder air at the surface. This darker filled in area is actual precipitation, and it's on the cold side of the storm to the northwest of that low pressure system. So you're getting a lot of overrunning frozen precipitation on this particular day, February 6th of 1980 on the weather chart. You look at the upper level map here, 500 millibar chart, 18,000 feet for 7 a.m. that morning, and you'll notice this troughing feature, the shortwave trough, a closed upper level low situated over the southern point of Lake Michigan. And so we have a nice becoming negatively tilted, that negatively tilted trough, the axis extending from northwest to southeast, and you're getting upper level divergence or the removal of mass aloft. This is directional diffluence. This is that directional divergence called diffluence, where you see spreading apart of these height contours at this particular point. That's where you're going to get your most significant lifting to occur in the vertical and your heaviest precipitation rates when you see something like this. Overall, this storm again, 6-7 February of 1980, resulted in over a foot of snow recorded at the Norfolk International Airport. Now let's take a look at the Circus blizzard of March 1980. Now remember what I said here when I broke the data down. There was only 2 significant or heavy snow events, more than 6 inches, that occurred in March. Well, the Circus blizzard of 1980 was one of those. This occurred on March 1st and 2nd of 1980. If you look at the pattern, so this was what? This was almost a month earlier, previous to the Circus blizzard. But in general, we have a very similar setup to the pattern here. The surface chart here, you see this interesting note again. Somebody hand wrote this in. This is for Sunday, March 2nd. The note literally says, later this day, worst blizzard on record. Hit eastern North Carolina and southeast Virginia. Coldest weather entire winter, mid-Atlantic states. So there's extremely cold air. You had a surface high pressure, an Arctic high. Of course, it's modified by the time it reaches the Red River Valley of Texas, but generally you got very cold air in place, and then you get this wave of low pressure to develop along a stalled frontal boundary over the western Atlantic, just off the coast of Georgia and the Carolinas. And then again, you're getting strong overrunning vertical lifting mechanisms here, where these darker shadings are, where precipitation was occurring on the surface analysis, generally this was at 7 a.m. Eastern time on the 2nd of March 1980. Looking over here on the right, you'll see the upper air pattern again at 500 millibars or 18,000 feet above the ground. We have a closed upper level low, which is a sign of a very intense or mature cyclone in the mid latitudes when you get a closed height contour around the upper low. Again, you do have a little bit of spreading apart, a little diffluence here in these height contours downstream of this shortwave trough axis, which, by the way, this shortwave trough axis extends all the way down to the Gulf of Mexico. Now, this Circus blizzard, why is it called the Circus blizzard? That's because the Barnum and Bailey Circus was in town, and what happened was the performers, the animals, and everybody, went to go see this circus. Whoever went to attend it, and basically everybody got stuck. Everybody got stuck in place because the snow was so heavy. It came down at such a fast rate. They actually called in National Guard to help move folks along because everything was just at a standstill across the area. 13.7 inches of snow. And this is the most snow, by the way, from one storm since 1892. So you want to know why I go back to the year 1980? This is really the reason. Because if we look back at the snowfall events again, we look at 1892, there's 89, there's 2010, there's 1980, which we're talking about right now, the Circus blizzard. And then there's 1899, there's 1980. Now, previous to 1980 for particular record snowfall events, there really wasn't a heavy snowfall in this area. You had to go back to February 9 and 10 of 1948 to really, any earlier than previous to 1980. You had to go all the way back to 1948 for a significant event. Additionally, there is one down here, a 9.1 inch event, 1973. So it basically doesn't happen very often in the area. So that's a little bit of the shock to society, to the normal functioning of society around here. But just generally want to show you what this looked like. The next event I'm going to talk about was 17 and 19 February 1989. Now this 1989 winter, again, as I mentioned it earlier, as far as records in February of 89, it was the most snowfall ever in 1 month in the Hampton Roads area, specifically Norfolk. 24.4 inches of snow fell for the entire month of February. And then the one event we're about to look at, 15.4 inches of snow fell in the one event. That's second all time on the top 15 list. So very heavy snowfall. This was the second highest total behind 1892. So this one even beat the Circus blizzard at 13.7 inches, okay? Here's the surface analysis, again, courtesy of NOAA Daily Weather Maps for Saturday, February 18th of 1989. Very similar setup. I mean, we got an Arctic high to the north. So we have plenty of cold air that is funneled in at the low levels down into the mid-Atlantic. We have a little bit of a cold air wedge or cold air damming. I can tell you that by the way these isobars, lines of equal pressure, are kinked. So you got cold air damming in place, cold air east of the Appalachians, get a wave of low pressure to develop along the stall boundary, and that's far enough offshore to where you're getting the heaviest precip, generally along the coastal sections of the Carolinas up to Virginia. There's that signature of very cold Arctic high to the north. Now looking at the 500 millibar chart for this particular day on the February 18th, 1989, again, you see a flow from Siberia, a more cross-polar flow. At the upper levels, the winds coming in from the northwest, which is pretty much that's putting that environment in place temperature-wise, what you need, the thermal environment, cold enough, in place prior to the precip falling from the higher aloft to the ground. You have cold enough air going on. Let's take a look at the next event. This was 24 February 89. So we're still in 89, we're still in February. And this is the other thing I wanted to mention about the Hampton Roads winters. You might be in a snow drought for a while, but then all of a sudden you can end up getting two significant snow events over a short period of time. We talked about the 17 and 19 February 89 storm, and then look, just a week later you have the 24 February 89 storm, where an additional 8.6 inches of snow fell, was recorded at the Norfolk International Airport, adding to that very high snowfall total for the month of February 89. Here's the surface chart for 24 February 89. You had an area of low pressure which was intensifying or deepening just off the vacapes. Again, you have this cold high to the north. See this over eastern Canada? That clockwise flow around that high is bringing northerly winds from eastern Canada straight down into eastern Virginia, into the eastern Carolinas. And your air is cold enough for snow. And the track of the low pressure is far enough offshore to where you're not having this warm front work its way from east to west into the area, allowing that marine air to come in and warm the planetary boundary layer just enough to cause a cold rain. This is all snow here based on the track. Here is the 500 millibar chart, 18,000 foot chart, showing a closed upper level low positioned generally in the vicinity of North Carolina and Virginia with this particular event. And you notice it's taking on more of a negative tilt to this shortwave trough, more of a trough axis from northwest to southeast. So everything is really lining up here, a little speed divergence downstream. And yeah, you got the ingredients for a really good snowstorm, another one of the heavy snow events in the past for Norfolk area. This one here, I was so bummed because I missed this one, and being a snow buff, I can't be totally upset because at the time it was over the holidays and I ended up going back to the Midwest. And I'll tell you what, back there I ended up getting 3 particular snow events, which probably totaled about 9 inches, maybe 10 inches of snow back there, if I remember right. There were 3 specific snowfall events back in the Midwest while I was away from southeastern Virginia during this event. But man, I missed the big one here. I mean, I would have loved to have stayed here to witness this one. I call this one the Christmas miracle because the odds of a white Christmas in Hampton Roads are very slim. And the fact that, the criteria typically for a white Christmas is 1 inch of snow on the ground as of 7 a.m. Christmas morning, okay? So this didn't quite meet the white Christmas criteria because the snow didn't start till later in the day on Christmas. But this was a significant event. Look at the surface chart here. 1032 millibar Arctic high, generally over Minnesota, okay? A strong clockwise flow around it. You got strong northerly winds from Illinois all the way to southeast Virginia and the eastern Carolinas. This blue dash line, by the way, is the freezing line, the 32-degree Fahrenheit line. So theoretically, anything to the left or to the northwest of this blue dash line or to the north of it should see all snow. So look how far south that 32-degree isotherm got. And look at this low pressure offshore. This is an intense system. You had really good mesoscale banding on the northwest side of the storm. The deformation zone is what it's called, the northwest of the surface low. And it was just a heavy snowfall rate across southeast Virginia and eastern North Carolina. And then here on the right, showing you the upper air pattern at 500 millibars again. There's that closed upper low again. See that? Very similar to the February 89 event. See where that closed upper level low is? Very similar. And you're getting this deep shortwave trough. You got colder air coming down north of the main jet stream axis. You got lift in the left front quadrant. I don't have the speeds of the jet stream on this particular chart. I'm not showing you a 300 millibar chart, but I guarantee you, just looking at this, how close these height contours are to each other, there most likely was some sort of jet streak or higher accelerated region of air within the jet core. We were most likely in the left front quadrant, very favorable lifting quadrant of that jet streak. I call it the Christmas miracle. As snow began falling on Christmas Day 2010, the total snowfall was 14.2 inches. Now this was the 3rd highest snow event behind 1892 and 1980. Moving on now to another recent event. This is even more recent, was the 3 to 4 January 2018 storm. This one was a monster, okay? This one definitely underwent bombogenesis. This is when the pressure drops. We call it a meteorological bomb when the barometric pressure drops 24 millibars, at a minimum 24 millibars over a 24-hour period. And you can just see these solid lines wrapping around this area of low pressure offshore of Capes, and this is extremely strong winds. This is an extremely intense system. What a great track for a major snow event again across southeastern Virginia, where you see this freezing line, the blue dash line. Anything to the west of that is cold enough for all snow, and all snow it was. And just amazingly enough, there was accumulating snow down to Georgia, Charleston, South Carolina. I believe got 8 inches out of this. Parts of eastern North Carolina got quite a bit as well, 5 to 10 inches there. And then across the Hampton Roads cities, there was a blizzard warning. 10.8 inches of snow was recorded at the Norfolk airport for this particular event. And this thing just got stronger as it went up off the New England coast. New Jersey, northward to New York, they got buried with almost 2 feet of snow with this one, if my memory serves right. So again, see the track of the storm? Offshore, right? And then look at the upper level charts here. Notice this trough digging in across the eastern U.S. again. Just really impressive, starting to go negative. The tilt of the trough, which indicates a very intense surface system, a rapid removal of divergence or mass aloft, and yeah. So I wanted to cover just a couple more slides in tonight's video. I want to talk about the favorable synoptic pattern for snowstorms across the Hampton Roads areas. Now, I learned a lot by just observations in the area and just paying attention to the weather charts. And that's kind of like what I'm sharing with you right now. I showed you some of these weather charts of some of the bigger events. As a snow lover, I've been very disappointed too with the winds coming in off the water. That sometimes can be disappointing because you could start off as a heavy wet snow and then it'll just go over to a cold, nasty rain. But here are some of the favorable synoptic ingredients that we look for a snowstorm at Hampton Roads. First thing I'm going to mention is that cold surface high pressure, generally to the north or to the northwest. You want to be on that front side of the surface high pressure system. It's a cold Arctic high that's coming down from Canada. You want to be on the east side of it to where you're getting that persistent northerly wind flow, which is going to funnel in colder air from the north. That's the first thing you want for an ingredient. The second thing is you want that deep upper level trough. You want it to dig fairly deep. If you get a trough axis all the way down the Gulf Coast, that's even better. So you need a very deep trough. You need a more of a meridional jet stream pattern is what I'm getting at. A strong baroclinic zone, you want that to set up generally along a stationary frontal boundary there in the northern Gulf of Mexico or just potentially offshore the southeastern U.S. coast. That will separate that Arctic air mass to the northwest side of the boundary and then the maritime tropical warm moist air to the southeast of that boundary. Now, the stronger that thermal contrast, the greater the probability for an intense storm system. Those storm systems, the potential energy is going to tap into that temperature gradient or difference across that Arctic front. At 300 millibar level or at 30,000 feet, we want a jet streak in place, an acceleration of those wind speeds or velocities within that jet core axis itself. And typically we want to be in the area beneath that left front or the right rear quadrant of that jet streak. That's the favorable areas where you get upper level divergence, removal of mass aloft, and a very strong deepening system at the surface. That's going to allow for low level surface convergence to kick in once you get that upper level divergence aloft. And then storm track is typically favorable for these snowstorms across Hampton Roads. What I've observed in the past and from research is generally 150 miles offshore is a good area, a good spot to be. The trick with these storm tracks for Hampton Roads that get snow, oh, it is tricky, all right. You don't want the storm track too far offshore because then all the dynamics and the vertical lifting is too far offshore, all the precipitation remains offshore. You don't want that storm track too close to Hampton Roads or to the coast in general because then it will act to drag in more of that marine air. It'll inject it into the system, and that's where you're going to get more of that cold rain across Hampton Roads. But then if you drive 100 miles inland towards Richmond, they generally like that setup because that's usually when they get their heaviest snow events in Richmond and along Interstate 95. So in general, I call that marine air contamination if the storm track is just too close to the coast. Gives us a cold rain scenario for Hampton Roads, but then gives that Richmond area heavier snowfall in that storm's deformation zone, the backside of the surface low. And typically you're going to see the heaviest snow about 100 to 150 miles to the northwest of the surface low. Or other rules of thumb that you like to look at is generally at the track of the 500 millibar low, which is generally right here. Wherever this thing goes, the 500 millibar low is generally where your heaviest snow is going to fall. Now, what could be some of the causes of this recent uptick in heavy snow events across Hampton Roads cities? Let's go back one more time before I get into that. Let's look at this. Let's go back to 1980. All right, let's just look at the top 5 snowfall events. Since 1980, how many do we have in this top 5? one, the one in February of '89. We have the one in December 2010, and we have the Circus blizzard in March of 1980. So three out of the five events, three of the five top five daily, or not daily, three of the top five snowfall events, all-time snowfall events in Norfolk, have occurred since 1980. And then if I even went down here, I could say four out of six. Here's 1980. Okay. So why the increased frequency? Let's look at some of the causes. Arctic amplification could be a potential cause. All right. What is Arctic amplification? That's basically telling us that the Arctic is warming twice as fast as mid-latitude locations. This is going to lead to a weaker thermal or temperature contrast across the latitude belts and an overall weaker jet stream in general. Because if you warm the Arctic twice as fast as the mid-latitude, specifically in wintertime, your temperature gradient from north to south isn't going to be as great, and that's going to act to weaken the overall polar front jet stream. And when you get a weaker polar front jet stream, that tends to have more wiggles in the jet stream or waviness in the jet stream. So that jet stream becomes more meridional, where you get deep troughs or huge high amplitude blocking ridges. And so you get more of a stronger, the colder air is allowed to really come down further south in the mid latitudes with that kind of weaker jet. And that thermal contrast, since it's weaker, in general, you're going to get that weaker jet. The weakening of the stratospheric polar vortex is another potential cause of these increased frequencies of heavy snow events in the Hampton Roads area, just generally in the mid-Atlantic. That stratospheric polar vortex, we're starting to see more frequent cases of it being disrupted. What I mean by disrupted is becoming stretched out, being weakened by what's known as wave activity flux, as energy transfers from the troposphere into the stratosphere. The favorable positions of those upper level high pressure systems, upper level highs or upper level ridges, poking their way well north beyond the climatological norm into high latitudes, that tends to result in a weakening, that wave activity flux transfer from the troposphere to the stratosphere. The stratospheric warming events, where we have just some really strong warming events, the temperatures in the stratosphere, weakens the vortex, and it either displaces the vortex off the poles, stretches it. Also, it can divide it up and split it into two vortices. Sometimes they're referred to as daughter vortices. Research conducted by Cohen and et al., they have concluded that due to global warming and this Arctic amplification in particular, it's leading to greater frequency of weakened stratospheric polar vortex. And that results in a greater episode of Arctic air being injected into the middle latitudes. Meanwhile, the Arctic is just above normal. Places like Alaska have seen some warm winters. And so this very cold air in place is unusually or abnormally cold air from the Arctic getting down into the middle latitudes. That is a key ingredient for major snowstorms in general. Another possible cause of increased heavy snow frequency, this increased amounts of evaporation into the atmosphere due to the warmer oceans. If you have warmer oceans, generally you're going to have potentially greater evaporation rates from those warmer oceans, and that's going to result in more moisture being available or fuel for these intense East Coast cyclones, these nor'easters. And so once that excessive moisture is lifted into the air due to the excessive evaporation from a warmer surface, it's then lifted into the vertical, and you get more precipitation basically to be wrung out of the atmosphere, so heavier snow rates. And then weather whiplash. This is occurring. We're seeing more drastic temperature ranges, not just in Hampton Roads, Virginia cities, but across a lot of portions of the United States, especially in the northern U.S., where these temperature ranges during winter are becoming more erratic. They're more drastic and more widespread, and are occurring over shorter time periods. For example, you may see a high of 55 degrees in Hampton Roads cities one winter day, and the next day you're freezing. It's 35 degrees, and you're getting snow. So the atmosphere, I really believe with weather whiplash, the atmosphere is struggling to find a new point, and you notice the quotation marks, struggling to find a new point of thermal balance on a warming planet. The atmosphere is always trying to reach a level of equilibrium. That's why you see storm systems in the first place. They're a mechanism by which warmer air gets dragged further north towards the poles, and colder air is dragged further south on the backside of the storms toward the equator. And so you're getting a transfer of heat from the lower to higher latitudes in this process. And, thunderstorm on a hot summer day is another example of that thermal imbalance initially in the vertical, which eventually is, through the process of heavy rain showers with thunderstorms, tends to basically reestablish an equilibrium on a summer day. But these storm systems the atmosphere is trying its best to get things back to equilibrium as quick as possible. Greater temperature contrast on a warming planet, these more erratic weather whiplash temperatures on such short timescales can lead to more severe weather events, greater potential energy for stronger storm systems to develop. Okay, so I'm a big believer in this. You look at the law of thermodynamics, about energy cannot be created. Energy cannot be created or destroyed, right? It just changes form. So in general, these are what I really believe deep down inside could be responsible for causing these increasing heavy snow frequency events for the Hampton Roads cities. The weather whiplash applies across the United States in the winter season. Whether you live in Boston, whether you live in Minneapolis, whether you live in Chicago, whether where you live, you may notice a more wide range of temperatures throughout the winters days in general. And you look at summer season and you just don't have that, right? You don't have those kind of crazy temperature extremes from one day to the next like you do in wintertime. Winter is the season that's warming the most across the northern hemisphere with this global warming situation. Okay, that wraps the video up tonight, everybody. Wow, I get really passionate about these topics. I'm really curious. I'm always thinking. I'm always thinking about things as far as how the atmosphere works and trying to figure out the clues it presents. And all I can say is remain inquisitive as much as possible. Question the current state of affairs as far as like certain scientific areas, kind of always have that curious mind and let that curious mind lead you down to a path of discovery. And I'm a big believer in that. I really love to do this stuff. I like to look at the research and I make sure I get my facts right before I do these videos. And I just love to share this information with you guys watching. I do appreciate, again, everybody's subscription. I always say this, but I really mean it. I like the comments you guys provide. Some real interesting comments on the last video I made, particularly about the warming temperatures on the planet. Some great questions or some great comments and feedback in that forum. And I'm going to keep working on some interesting research projects, hopefully over the course of the winter. This type of stuff takes me time. It takes me effort. It takes me, looking at research papers of the past that others have worked on, and just really trying to figure out how everything kind of connects. But there's no doubt about it. The winters are warmer now. When's the last time you could really rely on a white Christmas or a colder December? It just seems like winter's starting later now. It almost seems like winter's going from January to March instead of February. Instead of December to February, it's going January to March instead. It just certain things I'm noticing, and you most likely are noticing the same thing. All right, that wraps things up tonight. I thank you so much again for subscribing to the Spot on Weather YouTube channel. Continue to follow me here, and I'll hopefully keep producing some great material here. I know I'll be doing some more teleconnections discussions coming up. Kind of like talking about the current weather pattern and potentially what could be occurring as we head down the road into the winter months. So that's all I've got for right now, everybody. Until next time, take care and God bless everyone.